Okay, so this is problem 20 on page 127. The first thing we're going to do is convert to Kelvin, because in this first row you can see that the temperature is in Celsius, and we need that to be in Kelvin to convert to use PV equals nRT. So right here, we're going to convert to Kelvin, so that's 19 plus 273 equals 292 Kelvin. So that's pretty straightforward. And then our next thing that we need to do is solve for X right here, which is the pressure. And we're doing PV equals nRT, so it's just basic algebra solving for X. So then X is going to equal 22.7 atmospheres, and notice that there's 3 sig figs there. So yeah, and I'm just gonna clear this out of the way. And then we're gonna add this to our table. Okay, so next we have to convert the moles to grams. So just looking at the first row, we're going to do this by first finding the molar mass, which is pretty straightforward. Just we know that there's 4 moles of carbon, so we're going to multiply that by the 12 grams per mole, which is the molar mass of carbon, and then doing the same for hydrogen and just adding those two up. And we're going to get that there's 96.5 grams of butane for this first one. So there we go, 96.5. Okay, and then the next row, again, as you can see, it's again in Celsius, so we're going to have to convert to Kelvin again. So 6 plus 273 is 279 degrees Kelvin. Oops. So there we go. And then also, we're going to have to find the moles. So we have 14 grams times the conversion factor here using the molar mass, and we're going to get that that equals 0.241 moles of butane. Alright, so let me just get this out of the way. And so we know that the temperature is 279 Kelvin, the moles is 0.241 moles, and then we're going to plug into PV equals nRT, and again, just solve for X, and X equals 6.17 liters. So I'm just going to fill in these two boxes and get rid of this. Okay, so next row, the pressure is in millimeters of mercury, so we're going to convert that to atmospheres. So we have 433 millimeters of mercury, and then we're going to basically just divide that by 760, which is the conversion factor, and that's going to equal 0.57 atmospheres. So then next, we're going to have to convert the milliliters to liters. That's a tricky one because sometimes you don't notice and it just looks like liters or something, so just be really careful with volume, because that can really trick you. So again, we just use the conversion factor, dimensional analysis, and get 0.0924 liters. So then we're going to do, oops, okay, okay, and we're going to do PV equals nRT. So we have P equals 0.57 atmospheres that we just solved for, and V equals 0.0924 liters, and just plug in and solve like we've been doing, and X equals 1.62 Kelvin. So we're going to put that right there into our table. Okay, and next we're going to find the grams because that's the next thing in this row to do. So just do some simple dimensional analysis, and we get 23 grams. So it's pretty self-explanatory, and I'm just going to fill that into the table. Okay. So then, as you can see in the next row, we have the pressure is in the units of bar, so we're going to have to convert that to atmospheres. So just using this conversion factor, we're going to get 1.72 atmospheres. And then next we're going to convert to Celsius first. Okay, so we're in Fahrenheit, so we're going to convert to Celsius, then to Kelvin. So we're going to use this formula, which is 98 degrees Fahrenheit, which is our given temperature, minus 32, and then multiply that by 5/9, which will get you 37 degrees Celsius. And then, so next step, converting to Kelvin, we have 37 plus 273 equals 310 degrees Kelvin. All right, and we're going to plug into PV equals nRT. So just the same as usual, and we're solving for moles here. So just solve for x, and then x is going to equal 0.585 moles. And we're going to just fill this into our table. And next, we're going to solve for grams. This is our last one. So we're just going to use dimensional analysis as we have for our other problems. And we get 34.0 grams is the amount of butane for this last row. And we're going to just fill that in, and we're all done. Thank you for watching.